in this video, we're going to be going through some homework questions you may encounter. So the first question is asking for the exact value of certain trigonometric ratios. So what that means is your answer should be somehow have no decimal places. And you shouldn't be relying on your calculator to get these answers. So how do we start this off? So in the previous video, we had 5 special angles, 0, 30, 45, 60, and 90 in the first quadrant. And there were 5 numbers that we took a while to get. Those were 0, you start from the smallest. You go to the next one, which is 1 over 2.5, root 2 over 2, which is close to 0.7, root 3 over 2, which is 0.8-ish, and then you have 1 is a max. The reason why 1 is a max is it's a unit circle. The maximum value you can get in a unit circle is 1 when it comes to sine and cos, x and y. And these actually are related to the x and the y on a unit circle. So imagine you had a 30 degrees, a 45 degree, and a 60 degree. We'll call this one 45. I'm going to put this 45, 30, and 60. And these numbers here that we had, these 5 numbers, are related to the x and the y coordinates. So let's start off. So x, is, as you recall, is equivalent to cos theta. Y is equivalent to sine theta. And this will tell us which numbers to look at. So sine 45, first step 1, sine 45, is that an x or the y? Well, it's a y. So we're going to go to the 45 degree triangle, so the y value. We're going to go to the 45 degree triangle over here. So imagine there was a triangle-ish, okay? All right. In this case, what is 45? 45 is the middle one. So this is the lower, higher, highest, and the highest in terms of degree. So 45, we're going to go from low to high. We're going to be using this one here because we know in 45 degrees, these two sides are the same and it's the middle. So I'm going to use the middle one. In this case, this is the x and the y are the same, so it doesn't really matter what it is. It's going to be root 2 over 2. So the next one is cos 60. Step 1, what is cos? Well, cos is going to be x. So we're going to go to the 6 degree over here, and we're going to look at the x. So this here is the x. If I were to draw my triangle here in blue, we notice that the x and the y, they're not the same. So what does that mean? We're going to be using either the 1/2 or the root 3 over 2. Because this one over here is only related to the 45 degree. So it's either this or this. Now this one here is smaller than this. So if you look at the picture here, which is the smaller, the x or the y? And it seems like the x is smaller. So we're going to be using the smaller value between these two. Because these two numbers are related to 30 and 60. Over 1 over 2. So the next question has 2 parts. So let's see what the first one part. So here we have tan 60. Now tan is not part of this, but tan is actually opposite over adjacent. In other words, let's go to the 60 degree triangle. I'll use green here, and we know that tan 60 is going to be opposite over adjacent, or y over x in this case. So meaning we want to have y over x divided by to the power of 2. So what is y in this triangle here? Well, we know that y is the bigger number and this x is the smaller number. So the bigger number between these two is going to be this one here. So in other words, we have root 3 over 2 divided by, well, what's x? Well, x is the smaller one because x in this triangle shape is smaller. 1 over 2 to the power of 2 minus, now we have to use the 30 degree triangle. Now the 30 degree triangle is this one here. Now 30 degrees sine. Now sine is the y. So let's look at this triangle, let's look at the y value. The y value is over here. Now in this shape, I can tell you right now that the y value is a lot smaller than the x value. Now between these two values, as I said, these two numbers are related to 30 and 60. Which one is smaller? It is the half. So now we're going to replace sine 30 with 1 over 2. Then in this case, we're going to just use BEDMAS. We're going to do division, multiply by the reciprocal to the power of 2. Double half is the same thing as 1. You have over 1. These two will reduce. You have root 3 squared minus 1, and then you end up getting 3 minus 1, which is 2. So let's do a reciprocal identity with the 90 degrees. So first things first, what's secant? Well, secant is the reciprocal of cosine. In other words, secant is the same thing as the reciprocal of x, which is 1 over x. So in this case, we're going to look at the 90-degree angle. Now, 90 degree is over here. That's your 90 degree. And there is no triangle here, but we do know the coordinates of this. The coordinates of this is 0 and 1. Now, by looking at what we have here, we have 1 over, and we're looking for the x. What's the x value of this? Oh, it's actually 0, 0. And you take your calculator, 1 divided by 0, what does that mean? Well, 1 divided by 0, you can't divide it by 0 because we talked about restrictions in the rationals unit where the denominator cannot be 0. So in this case, this is undefined. We'll do one more example. So let's choose a 0 degree and let's do a reciprocal. Let's do cotant, for example, cotant. All right, so cotant is the same thing. It's a reciprocal of tan. Is that correct? Yes, tan. And we know that tan, going back to this question, is y over x. So cotant is the reciprocal. In this case, we're going to have x over y. So where is 0 degrees here? Well, 0 degrees is on this green line here of a unit circle. So in this case, we do know the coordinates of it. It's pertaining to the 0 and the 1. In this case, it's going to be x comes first, 1 and 0. Now in our case, what is it in this question, in this green line we're referring to? So x is going to be 1 and y is going to be 0. Again, we have a similar ratio like the one before. It is undefined. So here we have a right-angled triangle where alpha, in this case, is 30 degrees, and we are asked to solve for the triangle. So solving for the triangle means to determine all the details of the triangle, all the angles and all the sides. So we have 90 degrees, we have 30 degrees, and over here this is going to be 60 degrees. All the angles in the triangle add up to 180, and all we're missing is, in this case, we'll call it the hypotenuse, and then in this case I'm going to just call it little a. Okay, so let's actually solve for the hypotenuse. So the hypotenuse, well, what do we know? Well, which angle are we going to choose? What reference angle are we going to choose? You can use 60 or the 30, but because they already give me 30, I'll just use 30 degrees as a reference angle. So this is my 30 degrees. So let's actually list the hypotenuse opposite and adjacent. That's my opposite. It's opposite right there. Hypotenuse is your opposite of the 90 degree, and this is going to be your adjacent. So let's solve for the hypotenuse. So in this case, we're going to be using 30 degrees. We're going to look for the hypotenuse, and we know the opposite. So OH, it's going to be so. So you get sine 30 degrees is equals to 4 over, I'll call it the H for hypotenuse. In this case, we're going to solve for H. What we're going to do is I'm going to multiply h on both sides, so that becomes h sine 30 degrees is equals to 4. When you multiply h on both sides, because you got to treat both sides the same when you solve an equation, the h's will be reduced and the h is left over. I don't want to have this number here because I want h by itself, and I'm going to divide both sides by sine 30, so divide by sine 30 degrees, and we have this. Now, sine 30, yes, some people do have calculators, but if you didn't have a calculator, sine 30 refers to, yes, one of the special angles. Now, in this case here, I'm going to draw the 30 degrees. I know the 30 degrees. I know that the y value is smaller than the x. And in this case, going back to those special numbers here, it's always referring to these numbers. And I'm sure if you have another way to evaluate these special angles, by all means, use it. I know that sine is 30. It's going to be this one here, the y value. This is the shorter one, so I'm going to be using the half. In other words, this is 4 divided by 1 over 2. You do that, it gives you a 8. So to solve for the other side, I don't really have to use trigonometry anymore because I don't want to deal with those special angles. I can actually use Pythagorean theorem, which is c squared, a squared plus b squared. Hypotenuse we just solved, which is 8 squared. And we're going to look for a squared, b squared, let's call it 4 squared. Then you just work things out. Plus 16, you bring the 64 over. and you end up getting 48 equals to a squared. Then you have the square root of 48 equals to a. And if you want to change this into a more mixed radical, we know that this is the same thing as this. And you have 4 root 3 is equals to a, exact values. No decimal places, exact values. There are many other ways to solve for this. You don't always have to use the 30 degrees. You can actually use 60 degrees, or if you use the 30 degrees, you don't have to solve for the hypotenuse first. You can solve for the a. There's many different orders you can do. So in this question, we're given a radius. So imagine you had a radius of 5. So here's 5 and 60. So from here to here is 5. And here we have a principal angle of 6 degrees. And you're looking for the coordinates. So we're here, x and y. So if you guys recall the coordinate formula, that xy for any point on a circle with any size radius is referred to, x is cos theta and sine theta, but what I just wrote is just for a unit circle. If you want it for any circle of any size, it's going to be r, the radius. Now in this case, my r is 5, and then I have cos 60 degrees, and then 5 sine 60 degrees, and I'm not going to go into details of how to get these numbers. Cos 60 is 1 over 2, and sine 60 is root 3 over 2. That gives me 5 over 2, and 5 root 3 over 2. So that means this is the actual coordinates of this. So the second way to address this, another alternative method, is to just draw a diagram. In this case, draw a triangle. This is 60 degrees, and we'll call this the y and this the x, because x is going this way and y is going up and down. And so we can use SOHCAHTOA to solve for this. So let's, if we were to solve for y, so y in this case is opposite over the hypotenuse, and that becomes opposite hypotenuse. We use sine 60 degrees is equals to opposite, which is the y, over hypotenuse is the 5, and then we have to figure out the sine 60. So regardless, you're going to have to address the trig ratios regardless. So I know that sine 60 is root 3 over 2, and that's y over 5 equals to y over 5. And then because I only want to solve for y, I don't want the divided by 5. Divided by 5, opposite inverse operation is multiply by 5. So we're going to multiply it by 5 on both sides, and we end up getting 5 root 3 over 2 is equals to y. Oh, and you notice this y and this y are exactly the same. Two different methods-ish, we get the same result. So I'm not going to do the one for the x, because x is the same idea, but instead of sine 60, you're going to be using cos 60 adjacent, which is adjacent over 5, and you do all the same steps, and you will end up getting 5 over 2 at the end.